All right, so the good news is not most of this, but a good chunk of this, I would say, is review. We did talk about this stuff in Algebra 2. It obviously takes a different approach at some point, but it is a lot of review. So we're talking about like sine, cosine, and tangent in two ways. One is from your triangle, the other is from your circle. So what kind of angle are we drawing, right? This is just some vocab terminology. There's going to be an initial side, which is where your angle starts. There's a terminal side, which is where it ends, and the vertex is where it meets. Our general direction, which will be counterclockwise, that would be positive, and on our clockwise would actually be negative. So that's what that arrow is going to tell you, which direction you're going. Anything in standard position will start with the initial side on your x-axis pointing to the right. So this is our initial side here, okay? If the initial side is at 0, then it is called standard position. And like I just said, if I go counterclockwise, then it is a positive positive angle, and if I go clockwise, then it's a negative angle. Everything you do will be in radians. So where last year we did a combination, right? We talked about it in degrees, and then we talked about it in radians. Everything in AP is focused around radians, okay? So that's one major difference. The definition of a radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So if you look at that first one, if I made an angle from 2 radii, okay, and say that radius, no matter what the value is, let's say it's 1, let's say it's 2, let's say it's 3. In a unit circle, it would be 1. If I took that same thing and I bent it around the edges and it had the same length, that's what 1 radian is. So in a unit circle, our radius is 1. So if our radius on each of those green segments would be 1, and if I could take and fold, like if I took a piece of string or something that was 1 unit long and I rounded it like around the edge where that arc is, then that's called an intercepted arc. And that intercepted arc is 1 radian. So if you think about if I go all the way around a circle, 1 full circle is 2 radians. And that comes, if we put it in terms of pi, it would be 2 pi. Or sorry, I highlighted the wrong one. This is 3 radians. All the way around the circle is 2 pi radians. This right here is 2 radians. This is 3 radians. If I kept going to here, it's 4. If I kept going to there, it's 5. If I went all the way around, it's actually 6.28 radians because it's the equivalent of 2 pi. So what you're going to have to do is estimate it in terms of pi and then not in terms of pi. So hopefully this one helps a little bit, okay? If I go all the way around my circle, I just said it, but if my radius is 1, what measurement goes all the way around your circle? What's that measurement called? The circumference, right, would be all the way around your circle. How do you find circumference?
2 pi r.
2 pi r. And if my radius is 1, then what's the circumference? 2 pi. So a unit circle has a radius of 1, which means a full circle all the way around is 2 pi. Now, if I wanted a numeric equivalent of that without pi in it, what do we approximate pi as? 3.14. So 2 times 3.14 would be what? 6.28. So 2 pi would also be 6.28. So you'll see something that could say, where is 5 pi? But you could also see something, where is 5? And you have to know those are 2 different things, okay? 5 pi is actually going around your circle 2.5 times. 5 would fall somewhere in that 4th quadrant because it's in between those edges, yeah.
What do you mean going around 2.5?
Like, we'll talk about coterminals in a second, but every time you go around your circle, it's 2 pi. So if it was 5 pi, this would be 2, right? This would be 4. This would be 5. Yeah, we'll talk about that more in a second, though. So now if I go to the third one, cut that in half. What is half of 2 pi? Pi. So from just the first, like my terminal side, or my initial side, falling my terminal side at the left, that would be pi. And without, in terms of pi, that same value would be what? Pi is equal to 3.14. So that halfway is 3.14 radians. So if it said something like, where is 3 radians, I know it's a little bit less than that. Yeah.
Wait, so are we always assuming that the radius is 1?
When it's asking for the specific angle measurements, yes. And then when we get into sine and cosine, you'll see that's a little bit different.
Okay. Is
Yep.
there someone who loves me?
Yes. Santi, yeah. Thank you. All right, so now let's say halfway between, so at quarter 1, we're at 1/2 pi at the top there. I shouldn't have highlighted the whole thing. Halfway, we're at pi over 2 at the top. Now, if that was in terms, or not in terms of pi, that would be taking like 3.14 and dividing it by 2. So you're looking at like a 1.6-ish if we're to round it. This would be like 1.6 radians without pi. Yeah.
Why would you approximate that one but not the other?
What do you mean?
It's like, wouldn't it be 1.57?
Right. No. It's exact. It's an approximation. You can make it whatever you want. 1.57, 1.6. It's the same thing. Yeah. We're not going to get accurate enough. So if it gave you pi over 2, I expect you to go exactly where it is. But if it gives you 1.7, I'm not expecting you to know exactly where it is over here. I'm expecting you to know it's in quadrant 2, if that makes sense. That would be as accurate as you need to get, really. And then the last one at the bottom, and I know it's the second one as we move from left to right, but the last one is 3 pi over 2, and that is 1 and 1/2 pi. So this is halfway between the 3.14 and the 6.28, okay? So if I were to take this as 3.14 and this is 6.28, I would say 4 is probably around here, 5 is probably around there. This is going to be midway between them. Oh, there's such a lag. All right, so we have to know again, most likely, and you're going to see these back and forth, in terms of pi and then not terms in pi, and part of it will just ask you what quadrant it's in. But then we're going to eventually get to the signs on the positive, like all students take calculus, the signs of sine, cosine, tangent, all that stuff will come from the location of those quadrants, so it's important to understand them. All right, example 1, back to basics, literally says, name the angles that are in standard position and give the initial ray and terminal ray of each angle. I'm going to say just the positive, so we don't have to go back the other way. So just go counterclockwise. So one angle, well, they all start with this ray because that's the initial ray, right? But what's one of the terminal rays? DB. So I could say this would be angle BDC. What's the initial ray? Ray DC. Make sure that the D gets the dot and the C gets the arrow. And what's the terminal ray? DB, good. And again, make sure the D gets the dot, or not dot, but not arrow, and the B gets the arrow.
What does standard position mean again?
It means that the initial side is on the x-axis on the right-hand side. Like where DC is, has to be on that line. All right, now what's the other angle that's there?
ADC.
Good. ADC is the other angle. And what's the initial ray? DC. And what's the terminal ray? DA. Yeah.
Does it have to be in that order? Like, could you have done AD?
As long as the arrow's over the A.
Why is it?
Because the D is the point. The A is the direction it's going in. So it could be AD, but the arrow would have to be pointed that way. As long as the right one gets the right arrow. And we could keep going. Like I could say CDA is an angle. And I could keep going and do my negative angle. You don't have to worry about that stuff. This is talking about just the basic 2 angles that you see there. Okay? Same is going to ask you on homework. Just give those basic 2 angles. All right, now we're talking about coterminal angles. And again, this is something that hopefully sounds familiar because this was discussed in Algebra 2 Honors. But a coterminal angle, or coterminal angles, are angles in standard position that have the same terminal side. So, for example, if I said to draw pi over 2, my angle would be here. It would start at 0 and it would go to the top where pi over 2 is. But if I said to draw 5 pi over 2, it's the same angle because 5 over 2 is the same thing as saying 2 and 1/2 pi. So if I went around my circle 2 pi, I'd go all the way around one time. That would take care of the whole number part of that. And then one more 1/2 pi puts it in the same spot. These are called coterminal angles. They have the same start and the same finish, but the number of rotations is different. The way we find coterminal angles is by adding and subtracting 2 pi. So if I want to get a bigger coterminal angle, I add 2 pi. If I want to get a smaller coterminal, I subtract 2 pi. So if I had something like 17 pi and I wanted to know where its location was, I could literally subtract multiples of 2. So I could go 2, 4, 6, 8, 10, all the way up to 16. And I would get that the same location, that has the same location as pi, okay? The rule on whole numbers is the evens are always on the right. The odds are always on the left. So if I asked you to find 131 pi, where would it be? On the left, okay? Do I want you to have to subtract 2 pi until you get there? No, God, no. Okay? Yeah.
Can you show that really quick, like what you mean by that? Or,
Like how I would get to 131 pi? You mean? Or
just
what?
Even and odd. Like,
So if you just think about, like, we said that the halfway around the circle was pi, right? Here to here, this is pi.
okay.
So I could keep going. 2 pi, 3 pi, 4 pi, 5 pi. And that pattern is always going to be the same. Odd on the left, even on the right. All right, so we just said there's 2 ways to do these. One is I could take that 2 pi over 4 and I could subtract 2 pi from it to find my next terminal angle, right? Or I could look at my 2.4. I could separate out and I would get 2 and then 0.4. The 2 tells you, where's the even whole number? On the right-hand side. All right, now we're getting into arc length. So we also did these last year, I think, actually. I'm not sure. Did we? Yeah, right? SOR, yeah. So the order of the letters is S equals R, theta. I remember it as SOR, so you can reverse those. So it's S equals theta R. And the biggest rule is that theta has to be in radians. So last year we would take something that was in degrees, we would convert it to radians, and we would use it. You're already in radians because everything we're doing is in radians. So these kinds of questions are just going to give you 2 of those 3 pieces of information and ask you for the third, and they might be different. It might give you theta and the radius. It might give you the arc length and theta, and you're solving for the radius, and it might give you the arc length and the radius, and you're solving for theta. These should be super easy. You're either multiplying or dividing, okay? And these you'll have a calculator for, because you'll see the numbers get weird, like this, okay? It says, example 3 says, below are the measurements of a circle's radius with an angle within the circle or the arc subtended by the angle. And subtended just means an arc formed by an angle. So like literally the chunk of the arc that's formed by the angle. That subtended is a weird word. It just means the arc formed, okay? But it is the word that they use. Sketch the angle on the axis and then find the missing value. So A says your radius is 3.4 and the length of the arc subtended by an angle is 1.23. Find the measure of the angle. So we're looking for theta here. So first of all, well, it says below are the measurements of the angle, blah, 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 blah. Sketch the angle. I don't have the angle yet. What I do have is the length of the arc, which is 1.3. That's your S, or 1.23. And I have the radius, which is 3.4. So using SOR, S is 1.23 equals the radius is 3.4 times theta, and then literally just divide. And you'll have your calculator for this stuff. So 1.23 divided by 3.4. gives me theta is 0.361. So we're going to keep it as 36. And this would be in radians. Now notice there's no pi here, right? So when I go to graph this, I have to keep it out, not in terms of pi. So we said this was really 3.14. Half of that was 1.5, 1.6, okay? Which means 0.36 radians is going to be small, and it's going to be in my first quadrant.
How realistically do you have to sketch it?
As long as you're close, I would say. It doesn't have to be perfect. That should probably even be smaller than it is because half of 1.6 is 0.8 and I made it almost close to that. So as long as I would say it's in the right half of the quadrant, that's fine. All right, B says an angle. So now I've got theta. An angle in radians is 0.8 pi. And the length of the arc subtended by the angle is 16.9. So this is the length, or S. What's the radius of the circle? Now I have my angle to draw, but it's in terms of pi. So it's 0.8 pi, which is bigger than a half pi, but smaller than a whole pi, right? So my angle is in that second quadrant, pretty close to my x-axis. And then using SOAR again, S is 16.9, theta is 0.8 pi. I need to find R. I just divide both sides by 0.8 pi. And I get 6.724, so 6.72. If it gave you a unit, pay attention to it. Like if it gave you inches or centimeters, obviously pay attention to it. If it doesn't, you don't need to include it. Questions so far?
What was the answer?
6.72. You're welcome. All right, now we bring back in SOHCAHTOA. So hopefully we know this acronym, right? Sine equals opposite over hypotenuse. That's your SOH. CAH is cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So we're going to overlap this into a circle in a little bit. But for right now, use the left side, right? So if I wanted to find the sine of theta, what's my ratio? Using the letters that are there. A over C. Good. Cosine of theta. B over C. And tangent of theta. A over B. Now we go to our circle. Okay. What will change is your radius on your circle. So we're just going to call the radius R for now, because that may change. If it's just 1, then we can ignore the radius and we just do our X and Y's. But if the radius is anything other than 1, then we have to include it. So if I were to, let's say, close this in, not only is this part my radius, but this part is also my radius. So if I wanted to find, using SOHCAHTOA, if I wanted to find sine, it'd be the opposite side, which is the y coordinate, over the radius. If I wanted to find cosine, it'd be the adjacent side, which is the x over the radius. And if I wanted to find the tangent, it'd be the opposite over the adjacent, or the y over the x. That is if my radius is not 1. If my radius is 1, then this is just y, this is just x, this is still y over x. Yeah.
Where are you getting the triangle from?
If you closed in your triangle, here. So this is your initial side, right? The bottom side is still your initial side. This is still your terminal side, but in order to make a right triangle, you'd have to make this perpendicular. So you drop that down. This vertical distance is your y. This is still x here, so this horizontal distance is your x. And then the hypotenuse would be your radius.
But then you'd have to take like half of the radius for one of the sides.
No, because this is your radius, this is still your radius. The radius becomes the hypotenuse when you make the right triangle. This is your change in x, which let's just say I said my coordinate point was 1, 3. I'd go to the right 1. I'd go up 3. This is still the radius of your circle.
Oh, okay.
Does that make sense?
Yeah.
Okay.
Because like what throws me off is that there's like a point here, like where it intersects.
Right, so that point, this point, and you'll see it in the diagrams, that point is what will give you the length of the radius. Like it will say how many units this is. It'll say it will be radius, comma, 0. And that's how you'll know what r is. If it's 1, then you literally ignore it, and you just use your x's and your y's. But if it's not 1, then you have to put it over the radius. Claire? Mm-hmm. So when we get to unit circle, like if your brain starts to go to unit circle, when you get to unit circle, your radius is 1. So we only use y, x, and then y over x. But these questions today are not all based on something with a radius of 1. They look like this. Okay, it says find the value of each expression. That little symbol is just alpha. It's just another name for an angle, okay? So what information you have to get from this graph is 1, the r, what's your radius? 2, what's the coordinate point of the terminal side of your angle? This gray thing is telling you that that's my angle. This whole thing is my angle. This is the terminal side. So I'm using 2.6 and negative 5.4 as my x and my y, but what's my radius? 6, and that comes from there. So the sine is the y, negative 5.4 over 6. I'll go back and we'll actually get these into decimal form, but sometimes you'll be asked to leave them exact. The cosine is the x, which is 2.6 over 6. And the tangent is the y over the x, so negative 5.4 over 2.6. And then you'll keep, most of these will be kept in decimal form. This is negative 0.9. 2.6 divided by 6 is 0.433. So I'm going to keep it as 43 because we do 2 decimal places. And then 5.4 divided by 2.6, negative 2.076, which becomes 208. Maddie, you had your hand up.
Yeah, where's the triangle?
So this triangle, if I wanted to actually draw it, would be here. I make it with the x-axis. Does that make sense? Mm-hmm. This would be 6, because that's my radius. And then this is my y, which is negative 5.4, and this is my x, 2.6. Valeska. Yeah. If you want to see the triangle, you can draw it, but if not, you could just go over y over r. X, just do y over r, x over r, and y over x. Yeah? You're going to use it a bunch. Not a bunch, but at least in this section. Questions on that one? All right, do this last one, and then we're done. What's your radius this time? 1, which means the sine is what? Good. Negative 0.76 because it's the y coordinate. What's your cosine? Negative 0.065. And then the tangent, negative 0.076 over negative 0.065, which is 1.169 or 1.17. To find these?
Yeah.
Yeah.
So we don't have to worry about if there's another with x and y, we just look at the other one, like the bottom.
Right. Yeah. This triangle would be here. You're always going from your x-axis out to the angle. So your angle would be there. That would be your reference angle. So the x-coordinate, which is here, is negative 0.65. The y-coordinate, which would go here, is negative 0.76. And then the radius is 1. Always x-axis up or x-axis down to wherever the terminal angle is. You're making a reference angle, basically, if you're doing it that way. Questions? Okay.